Today we're on topic 5.1. We're going to look at example 1, and that is converting mixed radicals to entire radicals. In this example, we're supposed to express mixed radicals as entire radicals. So the first thing we have to do is look at the 7, the whole number 7 in front of the root 2, and express that under a root sign. In order to do that, we have to square the 7 and put it underneath a root sign. So now the square root of 7 squared is the same as 7. When I multiply that by root 2, I can simplify this by taking the 7 squared and expressing that as 49. Root 49 times root 2 can now be multiplied to give the final answer of root 98. Let's look at the second one. Well, first of all, root 98 is called the entire radical. 7 root 2 is called the mixed radical. In example B, we have a to the power of 4. Well, we got to square that and put it underneath a square root sign, times square root of a. A to the 4th squared is a to the 8th. Why can I say that? Well, because remember, 7 squared to the power of 3 is 7 to the power of 6. That's a power rule. And then a to the 8th times another a is a to the power of 9. In our third example, 5b is the whole part, so we're going to cube it and put it under the cubed root sign. That's being multiplied by the cubed root of 3b squared. Now when I cube the 5b cubed, I have to cube the 5 and the b. It's like 5b times 5b times 5b. That will give me 5 times 5 times 5, or 125, b times b times b, b cubed. Of course, that's times by the cubed root of 3b squared, and that's going to give you 3 times 125, which is 375, b to the power of 5. Why did I add the exponents this time? Well, remember the difference here. If I said 7 squared times 7 cubed, that's like 7 times 7 times another 3 sevenths. Altogether, you're multiplying 5 sevenths together, or you're getting 7 to the power of 5. Compared to what we just did earlier, 7 to the power of 2 cubed is like 7 squared times 7 squared times 7 squared, which, if you added the exponents, is 7 to the power of 6. Those are the two different rules that we're using. Don't confuse them. Okay, let's move on to our next one. But before we do that, this time when we're expressing entire radicals as mixed radicals, we have to find the biggest perfect square that we can find to divide into our root. When we look at root 200, we're going to make a list of perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 64, 81. I went all the way to 100. Now, from my list, what's the biggest one of those, the biggest perfect square I can divide into 200? Well, if I start at the top, because we want to start with the biggest we can go, does 100 go into 200? Yes. So I can express root 200 as root 100 times root 2. Now I know what root 100 is. It's 10. So I can write this as 10 root 2. And I'm done. Now the next one. I wrote it out first for you because c to the 9th is going to be broken into two parts. C to the 8th times c. The 4th root means that I can break it into 4. I need to find 4. Can I break c to the 8th into 4 groups? Yes. C squared times c squared times c squared times c squared would be c to the 8th, and that means I can find the 4th root of c to the 8th, which is c squared. Now I times that by the 4th root of c, and that's as far as I can go. In part C, what you do in this one is I write down first of all 2 roots. In the first root, I write what I can find the square root of. In the second root, it's what I can't find the square root of. When I look at 48, I have to break it into 2 parts. from my list, the biggest number I can divide into 48 is 16. Excuse me. So 48 is going to be 16 times 3. Now, the y to the 5th, I can find the square root of y squared, y to the 4th, or multiples of 2. So I'm going to write y to the 4th in the first bracket and y in the second bracket. Now the square root of 16y to the 4th is going to be 4y squared. So I could write that under the same root sign, 4y squared times 4y squared times 3y, and that'll leave me with a final answer of 4y squared root 3y. That's it for examples 1 and 2.